Okay, this project is the development of a solar-powered, biomass-fired plantain dryer for rural applications. As you can see, it is already functional because the sound you are hearing is actually the whirring of the suction fan. I'll get into all that.
Okay.
Now, this project consists of 3 systems. We have the solar system, we have the heat cylinder, which is also a system, or we could say the heat exchanger, and then we have the drying chamber. Now, what is the essence of this solar system? The solar system actually consists of 2 panels, each of 20 watts, and then making up 40 watts. They are used to power 2 fans. One fan is found at the inlet to the heat cylinder, which is also an heat exchanger. And the other fan, which has a cooling fin just above it, is found at the top of the drying chamber. Now, the essence of this fan above the drying chamber is to act as a blower. Right? Good. As a suction fan, rather. The fan here is a suction fan, and this here, which is found at the heat cylinder, is a blower. Now, the essence of this is to ensure that the heat that is being generated from the burner here, we used palm kernel as the fuel. We also made use of wood and then kerosene and everything just to start it up. The heat generated here is allowed to circulate through these pipes into the chamber with the use of that blower. Now, the rating of this fan is about 1 amps 12 volts fan, and then it ensures that the heated air is circulated into the drying chamber, in which you have the other fan, which is the suction fan. This suction fan draws up the moisture in the plantain, which is found in the drying chamber. Here you will see the plantain that is being dried. We have 3 trays here: tray 1, tray 2, tray 3. So you find out that this fan, the heated air coming in here, is being sucked up by the fan here. The fan here. This fan is a suction fan. Now you will find out that there are 2 strips of metal plate found there, 1 and 2. This is a heat distribution plate. This plate ensures that the heat being put into the chamber is kept and then is stored in this strip of metal, and then constant at a constant period the heat is dissipated, which ensures constant drying. Now, this thing has been working for the past 45-50 minutes now. You can see that the effect is quite distinct. It's already drying the plantain. Good. So the test being carried out on this has been going on, like I said, for about 50 minutes, and then afterwards the moisture content of this plantain will be checked, and then we'll be able to compare it with the plantain that were also dried in the sun. Now, it is to be noted that somewhere in here, there is something called a baffle. This baffle helps direct the flow of the air into the chamber, and then it sucks the heat for a long period of time, so that even when the fan is not being powered, or even when it is not being generated from the burner, there can still be circulation of heat into the drying chamber. We made use of mild steel in construction of the baffles. We would have preferred using aluminium because aluminium takes a shorter time in storing heat, has a higher thermoconductivity. So that's just one of the defects. Aluminium should have been used rather than mild steel, but we use mild steel. Now you find out that these things are supported with steel frames made of angle iron for the heat cylinder, the wood chamber also angle iron, steel frames. Then you find out that it has a chimney. There's a chimney here just above the heat cylinder. This ensures the dissipation of the flue gases. Like I mentioned earlier, one of the function of the baffles is to ensure that there is separation of the needed heated air that will dry the plantain and the exhaust, that is the unneeded one, which we actually call flue gases. So this carries out or takes away the flue gases out into the atmosphere, while the needed heated air is taken into the chamber through these pipes, which have been lagged using fiberglass and masking tape and insulating tape. Yeah, this is the fiberglass here, and this is the white insulating tape. Now this project actually cost us a couple of thousands, nothing less than over 70,000 naira in construction.
Parameters of the flue gases. You are talking to a layman. What are they made of? The flue gas. What are they made of?
So
the flue gas is made of charcoal.
Okay, the flue gases are made of charcoal, ashes,
and I guess something like that.
So on suits, they're made of charcoal gases and ashes and suits. And so, like I said, this here takes them out. So I think with this idea, we can do. The giant chamber is made of plywood. Should be noted, it's made of plywood of 25 millimeter thickness. Now, like I noted earlier, there are some defects, but it is expected that in a later design or later construction, some of these things will be noted. Thank you for listening. This project was actually constructed by Omorodion Etiosa of the Mechanical Engineering Department, Obafemi Awolowo University, and Akinsola Emmanuel, likewise of Mechanical Engineering, Obafemi Awolowo University, and were supervised by Dr. Muritala, class of 2014. Thank you for listening. It's my pleasure.